Hello, wonderful viewers. We have an interesting question that borders on how velocity of sound changes with temperature. Mind you, absolute temperature, okay? And if I must say, okay, let's go through the question. What is the velocity of sound at 100 degrees Celsius? If the velocity of sound at 0 degree Celsius is 340 meters per second, the examiner is very funny. He gave you the values of temperature in degrees Celsius, and if you use it, you'll be very wrong. Okay, let's go. So we're looking for velocity. So the velocity at 100, I will call it V2. So we're looking for V2 when T1 is 100. So 100 plus 273, so that will convert it to Kelvin, will give us 373 Kelvin. Okay, no, this is T2, I beg your pardon. All right, if the velocity of sound at 0, so if T1, which is 0 degrees Celsius, which is also equal to 273 Kelvin, all right, is 340 meters. So V1 here is 340 meters per second. So we're looking for V2. The truth is, from the original equation, which I wouldn't state here, I'll just go straight to this. Velocity is directly proportional to the square root of absolute temperature. From the original equation where I got this, I wouldn't go there for now. Okay, so let's do a little math. So this will be V equal to K root T, where K is constant. So which implies that V over root T is equal to K. Okay, what does this mean? That at any instant in time, the ratio of velocity to the square root of absolute temperature is a constant value. Therefore, I can conclude that V1 over root T1 is equal to V2 over root T2. That is the meaning of this, the constant here, okay? All right, so let's make V2 subject of the formula. So V2 equals V1, I'm going to cross multiply. V1 root T2 over root T1. So let's substitute. V1 is 340 times square root of T2, which is 373, divided by root T1, which is 273. So let's get our final answer. 340 times root 373 divided by root 273. That leaves us with 397 meters per second. So 397 meters per second is option B. It is this easy to handle only if you know what to do.